that when I get the that little preview screen of stream coming soon, that it plays a different track than whatever I'm playing on my machine. I was like bumping out to this other one. It's a little more hardcore. I'm gonna play it now just to get in the mood again, you know. How's that? You hear that? That will get you pumped up. I licensed this music years ago. It's good. All right, guys, who's ready? We are going to stream some game development. Just check my audio real quick. All right, how's that? All right, how's that? A little quiet. All right, how's that? Good enough. Let's get started, guys. If you're watching, thanks for watching. We got our game here that we've been working on off and on. Moved it over to Godot a little while back. And let me just show you what we got so far. Not much, but got some player movement. All right, so this background's ripped from the original game. It's a Game Boy game that we're making a successor to. The Queen animation is ours. And right now, you'll see the movement will stop. The camera movement will stop once it gets to the edge of the screen. Player will keep moving. And then when you walk away from the edge of the screen, camera starts following it. That's just like the original game. So that's basically what we did so far. It took me a while to figure out how to do that, but we got it working. We got diagonal movement. Cool. We got 2 tasks on my plate. We'll see which one's more interesting. But one thing is there's going to be a bigger map, obviously. And when you get to the edge of one screen, we'll call it, it will take you to the next square in the larger map, right? And so right now, when I go, let's say go all the way up, it actually just wraps around the screen. But you can imagine it loaded like a different area when it did that. That's basically what we want. So I want to work on that at some point. Flesh out like a whole larger map. We've got some background tile map thing that we want to do at some point. Another artist of ours gave us some assets to mess around with, so we might mess around with those and see if we can start figuring out how tile maps work. Because right now this is just a background. Like I can't actually go behind the sunflower here. So there's that. And then the other one that I think might be a little more coding, might be more fun for the stream, is some AI for the enemy. We don't have the first enemy in the game yet, as far as the art and the model goes for it, but we do have it. So another dev is going to be adding that in. So I won't necessarily do that now, but I could put like an AI script on this model just for testing out AI that would move around. Basic movement around the screen, probably stay in one area. The real AI in the final game will go across the map and target castles. I don't know what we're going to call them in the new game, if they're still castles or not, but the original game they were like castles, and you would try to take over the enemy castles. You try to take over theirs. And if you ever land on the same map or same screen as them, you would have to battle to the death. And you have like 4 or 5 characters. Like this is just one of them, the queen. And you can like zoom out to the overall map and like choose a different character, move around for a while. And it's all real time, meaning like if I just sit here, the rest of the guy's going to be moving, taking over my map. So obviously there's some AI involved there. But I want to just do the basic movement part, because right now we have it hooked up to the keyboard, obviously, pressing the keys on the keyboard, it moves around. We need a way to do that via code. So I could just jump in and probably code something, but I kind of want to see what people normally do in Godot for this. This is first time tuning in. Godot is the open source game engine that we're using. Very simple, very similar to like Game Maker. It does 3D as well, but I'm using it for 2D, obviously. Bum, 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 bum. All right, so I'm going to go to the docs here. Godot docs. what we find. All right, Godot 4.2. I don't know actually if we're on 4.2. I might need to update. 4.2.1. Okay, cool. Let's go full screen so I can swipe. Great. Go full screen with this guy too. Alrighty. Let's see what kind of guides we have here around AI. List of features, 2D tools, 2D physics, shaders, scripting. So maybe something in scripting. Audio input, possibly, but I don't think so. Navigation. What kind of navigation are they referring to? Internationalization, windowing and OS integration, mobile, XR, GUI system, animation, file formats, miscellaneous. Okay, so let's look at these. Scripting, object-oriented design pattern, signals, cross-language scripting, GD script, C#, GD extension. Go native. That was it for scripting. Okay, what was the next one? Navigation, A-star algorithm in 2D. Hey, that's actually what I want. Cool. Navigation meshes with dynamic obstacle avoidance in 2D and 3D. Generate navigation meshes from the editor. I actually was very unsure that this would be what it actually is. So A-star is an algorithm that's famous in game engineering for pathfinding. So let's see, did that actually link to, yeah, A-star. All right. An implementation of A-star for finding the shortest path between two vertices on a connected graph in 2D space. Description: an implementation of the A-star algorithm used to find the shortest path between two vertices on a connected graph in 2D space. Is that literally the same sentence? It is. See A-star 3D for a more thorough explanation on how to use this class. A-star 2D is a wrapper for A-star 3D that enforces 2D coordinates. Cool. So it's got some methods on here: compute cost, estimate cost. So I think if I had to remember my studies on this back in the day, it means cost in the sense that kind of like machine learning is weighted to go favor certain variables over others. I think this is like a cost to certain like pathfinding directions. We can watch a short video or something on this. Estimated cost, add points, are points connected, clear, connect points, disconnect points, get available point, get closest point in segment, get ID path, get point capacity, get point connections, get point count, get point IDs, get point path, get point position, get point weight scale, has point, is point disabled, remove point, reserve space, set point disabled, set point position, set point weight scale. So what does compute cost do? Let's see how close or far away I was. Called when computing the cost between two connected points. Okay, yes. Note that this function is hidden in the default A-star 2D class. So it's private but also hidden, so we shouldn't use it. Estimated cost, called when estimating the cost between a point and the path's ending point. The difference. Called when computing the cost between two connected points. Called when estimating the cost between a point and the path's ending point. Oh. Is that okay? So you have like 10 points and it can compute the cost of point 2 to point 10 or something. Add points adds a new point at the given position with a given identifier. The ID must be 0 or larger and the weight scale must be 0 or greater. The weight scale is multiplied by the result of compute cost when determining the overall cost of traveling across a segment from neighboring point to this point. Thus, all else being equal, the algorithm prefers point with lower weight scale to form a path. Adds the point 1, 0 with the weight scale 4 and ID 1. So ID 1, point is 1, 0, and the weight scale is 4. So we've got costs and we've got weights. If there already exists a point for the given ID, its position and weight scale are updated. Okay, so this is a update or create. So I just add point. Upsert point. Are points connected? Returns whether there is a connected segment between the given points. If bidirectional is false, returns whether movement from ID to ID is possible through the segment. There's all the points and segments. Creates a segment between the given points. If bidirectional is false, only movement from ID to ID is allowed, not the reverse. So you say add this point, and connect them. Okay, so we might be able to, just reading the docs here, trying to do it right, is, I lost all my viewers. That's just so boring. Why are you reading docs? If you want to learn, gotta do the work. Good hack away at it. Yeah, see, here's an example, right? Creating a single segment with 2 points, connecting them, right? I wonder if we did this, created this A star, and somehow gave it to the player, the character that the script is on. Could we say move on path or something? Could take this A star, like could we say, is there like a movement function or something that takes a path? That's what I want to know about. We haven't found that part. We know how to create a path, so imagine on one screen at least in our game picking a bunch of coordinates, creating a path out of it. Cool, but how do you get the AI to follow that path? Disconnect points. Pretty self-explanatory. Get available point ID, returns the next available point ID with no point associated to it. No point associated to it. Why do you need an ID for a point? I don't know what that means. Get closest point. Returns the ID of the closest point to position. Optionally, taking disabled points into account, returns -1 if there are no points in the points pool. If several points are the closest to position, the one with the smallest ID will be returned, ensuring a deterministic result. Get closest position in segment, returns the closest position to position that resides inside a segment between 2 connected points. Okay, so now we've got a segment, and now we're saying get closest point in segment, and this is your current position, I guess, or just saying give me the closest point to this point. So the point is 3, 3. And it returns, oh, I see. So it doesn't return 0, 1 or 0, 5. Returns 0, 3, which is between these two, because this is a line now. It's a segment. Sorry, I had a sneeze. Oh my gosh. All right, the result is in the segment that goes from y equals 0 to y equals 5. It's the closest position in the segment to the given point. Okay, makes sense. Get ID path. Returns an array with the IDs of the points that form the path found by A star 2D between the given points. The array is ordered from the starting point to the ending point of the path. Okay, so it's got 4 points in it. You're connecting each point to the next, and then you're saying get the ID of path 1, 3. 1, 3. So 1, 3 is not an explicit point, but it somehow returns an array of 1, 2, 3. Those must be the IDs. 1, 2, 3. Does not return 4. Why doesn't it return 4? Let's see if we can figure this out. Is 4 connected to anything? Yeah, 1 is connected to 4. So if 1 is connected to 2, 2 is connected to 3, 4 is connected to 3. And I think this means not bidirectional, if I had to guess. So the only way to get to 4 is from 1. What does that mean? What does that mean? If you change the second point's weight to 3, then the result will be 1, 4, 3 instead. Because now, even though the distance is longer, it's easier to get through point 4 than through point 2. How so? What is this? Oh, because there's a weight. It's preferring this one. Because this has higher weight than these, it's going to prefer this one. Okay, fine. But if you're starting at 1, 3, you think you'd be somewhere near 0.3, because at least it's on the same x-axis. And even the y is just as close as this one. But it goes with this one because it's got the same y. Okay, but they're saying if you change the weights, you would have chosen 0.4. See, that doesn't make sense. So you think you would have chosen 0.3. Let's read it again. If you change the second point's weight to 3, so this guy, then the result will be 1 or 3 instead, because now, even though the distance is longer, it's easier to get through 0.4 than through 0.2. Okay, so maybe I had that backwards. If it's got a higher weight, it avoids it? Because it didn't go through 2 this time. Does that mean a higher cost? What does it mean? All right, let's keep going. Returns the capacity of the structure back in the points, useful in conjunction with reserve space. Get point connections, return an array with the IDs of the points that form the connection with the given point. Add point, add point, add points, connect points, connect points. So this is connecting 1 to 2, 1 to 3. Neighbors, A star, get point connections, returns 2, 3. So get point connections 4.1 gives you 2 and 3. Because 1 is connected to 2 and 1 is connected to 3. Okay, that one makes sense. Returns the number of points currently in the points pool. Returns an array of all point IDs. Returns an array with the points that are in the path found by A star 2D between the given points. The array is ordered from the starting point to the ending point of the path. This method is not thread safe. If called from a thread, it will return an empty packed vector 2D array and will print an error message. Returns the position of the point associated with the given ID. Get point weight scale, returns the weight scale. Has point, returns whether a point associated with the given ID exists. Is point disabled, returns whether a point is disabled or not for pathfinding. By default, all points are enabled. Removes the point associated with the given ID from the points pool. Reserve space internally for num nodes points. Useful if you're adding a known large number of points at once, such as points on a grid. Now capacity must be greater or equal to old capacity. New capacity. Disables or enables the specified point for pathfinding, useful for making a temporary obstacle. Okay, so if we want to have a tree fall over and block the path, we could disable a point that would be under that tree. Okay, this sets the position for the point with the given ID. Sets the weight scale for the point with the given ID. The weight scale is multiplied by the result of the compute cost when determining the overall cost of traveling across a segment from a neighboring point to this point. Okay, that's A star 3D. A star 2D, A star grid 2D. An implementation of A star for finding the shortest path between two points on a partial 2D grid. A star 2D is a variety of A star 2D, or A star grid is that specialized for partial 2D grids. It is simpler to use because it doesn't require you to manually create points and connect them together. This class also supports multiple types of heuristics, modes of diagonal movement, and a jumping mode to speed up calculations. To use A star grid 2D, you only need to set the region of the grid, optionally set the cell size, and then call the update method. Okay, so we can create a region. How many cells do we want? And we could print path between 0, 0 and 3, 4. Get ID path, get point path. So this returns the IDs 0, 0, 1, 1, 2, 2, 3, 3, 3, 4. This returns the actual position, so 0, 16, 32. Okay. To remove a point from the pathfinding grid, it must be set as a solid from set point solid. Properties are cell size, heuristics, default compute heuristics, default estimate heuristics, diagonal mode, bool, jumping enabled, offset, region, size. So it can jump to the different points. Cool. Methods, compute costs. Let's go through these. Heuristic Euclidean. The Euclidean heuristic to be used for the pathfinding using the following formula: absolute 2id.x minus from id.x. So distance between the 2 and the from, the x and the y, get the square roots, the square, the x squared, dy squared, add them together. This is also the internal heuristic used in A star 3D and A star 2D by default with the inclusion of possible z-axis coordinate. Heuristic Manhattan, the Manhattan heuristic to be used for pathfinding using the following formula. Okay, this one's the x2 minus the from, and then add them together. This heuristic is intended to be used with 4 side orthogonal movements provided by setting the diagonal mode never. Heuristic octile, the octile heuristic to be used from the pathfinding using the following formula. Cool, so a bunch of different algorithms here. Resist the size heuristic. Enum, diagonal mode. The pathfinding algorithm will ignore solid neighbors around the target cell and allow passing using diagonals. That's if you say always, never. The pathfinding algorithm will ignore all diagonals and the way will be always orthogonal. At least one walkable. The pathfinding algorithm will avoid using diagonals if at least 2 obstacles have been placed around the neighboring cells of the specific path segment. Diagonal mode only if no obstacles. Diagonal mode max represents the size of the diagonal mode medium. Property descriptions, cell size, default compute heuristics, estimate heuristics, diagonal mode, jumping enabled, enables or disables jumping to skip up the intermediate points and speeds up the search algorithm. Currently toggling it on disables the consideration of weight scaling and pathfinding. Offset, the offset of the grid, which will be applied to calculate the resulting point position returned by get point path. If changed, update needs to be called before finding the next path. Region, the region of grid cells. Size. Cost. Estimate costs, clear. Fills solid region. Fills the given region on the grid with a specified value for the solid flag. Calling update is needed. Weight scale region. Fills the given region on the grid with the specified value for the weight scale. Vector I get ID path returns an array with the IDs of the points that form the path run A star 2D between the given points. Get point path, get point position, point weight scale is dirty, indicates the grid parameter or change and update needs to be called. Is in bounds returns true if x and y is a valid coordinate, i.e. if it is inside region equivalent to has point. Is in bound SV returns true if the ID vector is valid grid coordinate, i.e. if it is inside region equivalent to has point. What's the difference? Oh, this one's based on the ID. This one's based on the coordinates. Is point solid? Returns true if the point is disabled for pathfinding. By default, all points are enabled. Why is solid disabled? I don't know what solid means here. Disables or enables the specified point for pathfinding. Useful for making an obstacle. By default, all points are enabled. Okay, so solid means it's disabled. Why don't they just call it disabled? Calling update is not needed. Set point weight scale sets the weight scale for the point with the given ID. The weight scale is multiplied by the results of compute costs when determining the overall cost of traveling across the segment from a neighboring point. Yeah, so the higher the weight scale, the higher the cost. So we had that backwards earlier. Updates the internal state of the grid according to the parameters to repair it to search the path. All right, I wonder if we have an example of that. So before we go on, by the way, here's some math. Euclidean distance between the 2 points in Euclidean space. And then what happened at that heuristic? This is the miscellaneous video playback, movie maker mode, low-level access to servers, command line interface, support for C++ modules, license. Okay, so nothing about pathfinding or AI. Cool. So we read the bit about A star. Let's look, before we move on to how to implement it in Godot, I want to actually check one more thing, which is simple explanation of A star pathfinding. Oh my gosh, sun in my eyes. Here we go. This is what I wanted.
Welcome to this video on pathfinding. So in this first episode, we're going to be taking a look at how the A-star algorithm actually works.
This is Sebastian Leg.
In the future episodes, you've got a pretty good understanding of why it works and where we're going. Alright, so here we have a grid of nodes, the white nodes representing the walkable nodes.
Where were we? Okay.
So, of course, we're trying to find the shortest path from node A to node B. And what we need to do first, diagonally, is going to be the square root of 2, which is probably 1.4. So, quite a common practice is just to multiply those two numbers by 10, and to use the nice integer values of 10 across and vertically, and 14 for the diagonal. Alright, so I've removed the obstacles from them so you can see how the algorithm is going to run when there aren't any obstructions. So the algorithm begins by going to the starting node, node A over here, and looking at all of the surrounding nodes and calculating some values for each of them. So the values in the top left corner of each node are called the node's g-cost, and that is quite simply how far away that node is from the starting node. So this node in the top left corner has got a g-cost of 14, since it's just one diagonal move away from node A. In the top right corner of each node is the node's h-cost, which is basically the opposite of g-cost, is how far away the node is from the end node.
Oh.
This node is 2 diagonal moves away from the end node, so it's got a h-cost of 28.
That makes sense.
Now the big number is the node's f-cost, and that is very simply g-cost plus
h-cost.
So now the algorithm is going to look at all of these nodes.
It's the smallest one.
Choose the one with the lowest f-cost.
Makes sense.
and that is of course this 42 in the top left corner. So it will mark this now as closed, so it will appear red, and it will then calculate all of these values again for all of its surrounding nodes.
Why is going down
It's
one?
quite simple to see what's happening.
Isn't this interesting? Going down, unless you just didn't update it from A, but like 48 to down, to the left, and to the right. So obviously 42 is lower, so it doesn't matter. But wouldn't going down actually be much worse than going up or left? Because it's left and up. So why would you ever go down? Shouldn't that have a high cost? Did they just not update it from the first one? Let me check. Yeah, they just didn't update the 48 probably. I think that's a mistake.
To look at first, and that is
Should it be more like the 62 or something?
So it will mark this now as closed, so it will appear red, and it will then calculate all of these values again for all of its surrounding nodes. And it's quite simple to see what's happening here. These F costs are just staying the same as we move towards the target, because the G costs, the movement costs are increasing, and the H costs are decreasing, and they're sort of balancing each other out. So it basically explores the path straight to the end. Well, no point having pathfinding in your game if you're not going to have any obstacles. So let's add those back in and run through the algorithm once more and see what happens. So once again, we look at all the surrounding nodes and calculate their costs. And we'll go with this lowest F cost of 42. And now we have a scenario where we have 3 nodes, each with an equal F cost of 48. And
But right's faster. It doesn't know that though.
Decide which one to pick is we'll look at which one is closest to the end node. In other words, which one has the lowest H cost. This has an H cost of 38. This is also 38. And this is 24.
That's the wrong one. Doesn't know that though.
Now, as you can see, the
Limitation.
F costs are increasing each time, since we're not going in a straight line towards the end.
So is it actually going to go
The
back?
H costs are decreasing by a little bit each time. The G costs are increasing by even more, resulting in a more expensive path. So now the two nodes with the lowest F cost
Can it not go backwards?
to 48 over here.
It would get in a circle.
Same, H cost, so we can pretty much choose one at random. Let's go for
Yeah,
this
he
one
did.
here.
So he did turn around.
And now we have to look at the other one.
Oh, it didn't actually go there. Okay, it's just calculating before it even moves.
Promising node as it was, this 54 over here, and we explore that.
So still thinks that one's the
Now we'll
best.
look at this other node with an F cost of 54. But one thing I would like to draw your attention to quickly is the node just to the left of it with an F cost of 68. If we look at its...
That's tearing stuff up. Where's my mouse? Back your mouse. There it is.
G cost, it is currently 38, but if we look how far away it is actually from node A, it's just 10, 20, 30 away. So obviously this is coming on a path something like diagonally up here, 14, then across for 24, and then down diagonally to make 38. So as we explore this 54 over here, and explore all of its surrounding nodes, you'll see how the 68 updates to reflect the new best path to this node.
Okay.
So it now has an F cost of 60, and it is the most promising node on the map, so we'll explore that. And now we have a bunch of 62s to look at. Not much to say in the way of commentary here, just exploring all of these lowest F costs. Until now we come back to the 68, and we explore that, and we get to explore the other 68, and now we'll observe the same fact as we saw in the first example, with just a straight line to the end node, and the G costs and the H costs would balance each other out, and the F costs would change, and we'll just go straight to the end.
Got it.
So
Okay.
you can see how this is guaranteed to find the
We'll take the shortest path. Okay.
since
Just calculating it. It's not actually
moving in a straight
going.
line towards the end. The F costs are going to increase, and then it will start looking at the other potential options. Let's look at one final example. In this case,
It's an equal cost.
the G costs and the H costs, and I'm instead showing
Could go above or
basically
below.
indicating where these nodes have come from.
Is it 1, 2, 3, 4, 5?
You can see all of its surrounding nodes are now
2, 3, 4, 5. Or maybe the going from the bottom's faster.
Of course, the 64 and the 58 over here, even though they are, its neighbors are not updated to show that they're coming from this node, since it should be a worse path. In other words, if we have a higher F cost, if we were to get, say, this node over here, by going diagonally up and then down. So it will only update if it is in fact a better path that's being offered. So we continue by looking at this 58, and that yields the 66, so we go back to the 58 to begin. And now once again, just to demonstrate, you see that the 66 is coming on sort of slower diagonal path, so it will be much quicker to just go horizontally across. So as we explore this 58 and look at all the surrounding nodes, that node is going to update to reflect that.
Interesting.
And
I don't quite understand how it does that, but okay.
to the end now. So the point of these
It's not clear when it updates and when it doesn't, but
reach the end node, we can sort of retrace our steps and find the path that we took to get there. Alright, so while that is still hopefully fresh in your mind, let us look at how this would work in terms of the electrical programming. And so what I've done
what the
is
hell
a bit of
language is
pseudocode,
this? Okay, pseudo. That's my first guess.
not in any particular language, it's just basically a set of instructions. Alright, so to start off with, we create two lists. The first is called the open list, and this list is for storing all of the nodes for which we've already calculated the F cost. So in the diagrams I've been showing all the nodes that were colored green were the ones that were currently in the open list. Then the closed list is basically the set of nodes that have already been evaluated. So those are all of the ones that I sort of ticked off with red in the diagrams once we've looked at all of their neighbors. So once we've created those two lists, we add the starting node to the open list. So that's currently the only thing in the open list. And there's nothing, of course, at the start in the closed list. And then we enter a loop. So inside of the loop, we create a little temporary variable called our current node, and this is equal to the node in the open list with the lowest F cost. So at the beginning, that will of course be the starting node, since it's the only one in the open list.
Remove current note.
And remove the current from the open list, and we add it to the closed list. Then if the current node is the target
It's
node,
not. Keep going.
we found the path.
Look at each neighbor.
We can just exit out of the loop. Otherwise, we're going to go through each of the neighboring nodes of the current node. And first of all, if it's not traversable, or if it's in the closed list, then we'll just skip ahead to the next neighbor and ignore it. And if that's not the case, then we check a couple of things. So first of all, if the new path to the neighbor is shorter than the old path, so say for example that the neighbor is already in the open list, as we've seen in some of the diagrams, but then the new path is shorter, so we have to update that node to reflect that we found a better path to it. So if the neighbor is not already in the open list, then we set the F cost of the neighbor, which we do obviously by first calculating the G cost and the H cost, and then we set the parent of the neighbor to the current node. So that's what I was trying to show visually with the arrows. We sort of keep a reference to where that node came from, so that we can retrace the steps once we get to the end node. Then finally, if the neighbor is not in the open list, then we just add the neighbor to the open list, and we keep looping this, and eventually the current node is going to be equal to the target node, and the path we're looking found will exit out of it, and we'll just run a quick
Go through its parents. Never mind.
look at all of the parents going back from the end node, until we find the
The only part I don't quite get is this new path to neighbor is shorter part. That part I don't really get. I mean, this is just pseudocode, but let's see. So if the new path, what is new path in this case? Yeah, that part's just kind of vague.
Alright, so that's pretty much all there is to it. Of course, as we begin actually programming this in C# in the future episodes, we'll look at a couple of things a bit more in depth. But for now, I should hopefully give you a pretty good understanding of how AI works. And if you're unsure about anything, don't hesitate to leave a comment and I'll try to help you out.
Pretty cool.
Otherwise, I've also linked a couple of really good articles in the description.
All right. I like this guy. I'm going to subscribe. 32,000 likes. Awesome. Good video, dude. All right. Let's see if there's anything about use navigation agents. Okay, there's an agent. Interesting. Navigation agents are helper nodes that combine functionality for pathfinding, path following, and agent avoidance for a node 2D, 3D inheriting parent node. They facilitate common calls to the navigation server API on behalf of the parent actor node in a more convenient manner for beginners. 2D and 3D versions of navigation agents are available in Navigation Agent 2D and Navigation Agent 3D. For new navigation agent nodes will automatically join the default navigation map on the world 2D. Navigation agent nodes are optional and not a hard requirement to use the navigation system. Their entire functionality can be replaced with scripts and direct calls to the navigation server API. Navigation agent pathfinding. Navigation agents query a new navigation path on their current navigation map when their target position is set with a global position. The results of the pathfinding can be influenced with the following properties. The navigation layers. A bit mask can be used to limit the navigation meshes that the agent can see. The pathfinding algorithm controls how the pathfinding travels through the navigation mesh polygons and the path search. The path post-processing sets if or how the raw path corridor found by the pathfinding is altered before it is returned. The path metadata flag enable the collection of additional path point metadata returned by the path. Disabling path meta flags will disable related signal emissions on the agent. Navigation agent path following. After a target position has been set for the agent, the next position to follow in the path can be retrieved with the get next path position function. Once the next path position is received, move the parent actor node of the agent towards this path position in your own movement code. The navigation system never moves the parent node of navigation agent. The movement is entirely in the hands of the users and their custom scripts. Okay, so this navigation agent will help us decide where to move, but every update we need to move it? Okay. Navigation agents have their own internal logic to proceed with the current path and call for updates. Get next path position function is responsible for updating many of the agent's internal states and properties. The function should be repeatedly called once every physics process until is navigation finished, tells that the path is finished. The function should not be called after the target position or path end has been reached, as it can make the agent jitter in place due to repeated path updates. Always check very early in script with is navigation finished. If the path is already finished, the following properties influence the path following behavior. Path desired distance defines the distance at which the agent advances its internal path index to the next path position. The target desired distance defines the distance at which the agent considers the target position to be reached. Path max distance defines when an agent requests a new path because it was moved too far away from the current path point segment. The important updates are all triggered with the get next path position function when called in physics process. Navigation agents can be used with process but are still limited to a single update that happens in physics process. Script examples for various nodes commonly used in the navigation agent can be found in further below. Okay. So this might be what we're looking for. The path is returned empty. If an agent queries a path before the navigation map synchronization, e.g. in a ready function, the path might return empty. In this case, the getNextPath position function will return the same position as the agent parent node, and the agent will consider the path end reached. This is fixed by making a deferred call or using a callback, waiting for the navigation map change signal. Okay, good to know. The agent is stuck dancing between two positions. This is usually caused by very frequent path updates every single frame, either deliberate or by accident, e.g. max path distance set too short. The pathfinding needs to find the closest position that are valid on navigation mesh. If a new path is requested every single frame, the first path positions might end up switching constantly in front and behind the agent's current position, causing it to dance between. That's if you were trying to, like, I don't know, add obstacles or like adjust the path every frame as it's trying to navigate. Okay, that makes sense. The agent is backtracking sometimes. If an agent moves very fast, it might overshoot the path desired distance check without ever advancing the path index. This can lead to the agent backtracking to the path point now behind it until it passes the distance check to increase the path index, increase the desired distance according to your agent speed, and update the rate usually fixes this, as well as a more balanced navigation mesh polygon layout with not too many polygon edges cramped together in small spaces. The agent is sometimes looking backwards for a frame. Same as with stuck dancing agents between two positions, this is usually caused by very frequent path updates every single frame, depending on your navigation mesh layout, and especially when an agent is directly placed over a navigation mesh edge or edge connection. Expect path positions to be sometimes slightly behind your actor's current orientation. This happens due to precision issues and cannot always be avoided. This is usually only a visible problem if actors are instantly rotated to face the current path position. Okay, so now we know this is something that might happen. We can keep a lookout for it. We've got a viewer. What's up? Munir Wahood. How you doing, man? We're just reading docs, studying. We're gonna try to add some pathfinding to our game. Very basic, but before I jumped in and try to hack it, I'm gonna actually just read the Godot docs. This section explains how to use the navigation avoidance specific to navigation agents. In order for navigation agents to use the avoidance feature, the enable avoidance property must be set to true. Interesting. So we could tell it to like avoid the player, maybe, or something. Good to know. The velocity computed signal of the navigation agent node must be connected to receive the safe velocity calculation results. Not sure about that one. Use set velocity on the navigation agent mode in physics process to update the agent with the current velocity of the agent's parent node. While avoidance is enabled on the agent, the safe velocity vector will be received with the velocity computed signal every physics frame. This velocity vector should be used to move the navigation agent's parent node in order to avoid collision with other avoidance using agents or avoidance obstacles. Only other agents on the same map that are registered for avoidance themselves will be considered in the avoidance calculation. Okay. Following navigation agent properties are relevant for avoidance. Property height is available in 3D only. Height, together with the current global y-axis position of the agent, determines the vertical placement of the agent in the avoidance simulation. Agents using 2D avoidance will automatically ignore other agents or obstacles that are below or above them. The property radius controls the size of the avoidance circle, or in case 3D sphere, around the agent. This area describes the agent bodies and not the avoidance maneuver distance. Property neighbor distance controls the search radius of the agent, which is searching for other agents. Property max neighbors controls how many other agents are considered in the avoidance calculation. If they all have overlapping radius, a lower value reduces processing costs, but a too low value may result in agents ignoring the avoidance. The properties time horizon agents and time horizon obstacles control the avoidance prediction time for other agents or obstacles in seconds. When agents calculate their safe velocities, they choose velocities that can be kept for this amount of seconds without colliding with another avoidance object. The prediction time should be kept as low as possible, as agents will slow down their velocities to avoid collision in that time frame. The property max speed controls the maximum velocity allowed for the agent's avoidance calculation. If the agent's parents moves faster than this value, the avoidance safe velocity might not be accurate enough to avoid collision. The property use 3D avoidance switches the agent between the 2D avoidance XZ axis and the 3D avoidance XYZ axis. And the next update, note the game avoidance and 3D avoidance run in separate avoidance simulations, so agents split between them do not affect each other. The properties of avoidance layers and avoidance mask are bit mask similar to e.g. physics layers. Agents will only avoid other avoidance obstacles that are on the avoidance layer that matches at least one of their own avoidance mask bits. Avoidance priority makes agents with a higher priority ignore agents with a lower priority. This can be used to give certain agents more importance in the avoidance simulation, e.g. important NPCs characters, without constantly changing the entire avoidance layer or mask. Avoidance exists in its own space and it has no information from navigation meshes or physics collision. Behind the scene avoidance agents are just circles with different radius on a flat 2D plane or spheres in an otherwise empty 3D space. Navigation obstacles can be used to add some environment constraints to the avoidance simulations using navigation obstacles. Avoidance does not affect the pathfinding. It should be seen as an additional option for constantly moving objects that cannot be rebaked to a navigation mesh efficiently in order to move around them. Using the navigation agent enable avoidance property is the preferred option to toggle avoidance. The following code snippets can be used to toggle avoidance on agents, create or delete avoidance callbacks, or switch avoidance models. Okay, so this is a navigation agent 2D. Here's an agent. Get its RID. I don't know what that is. Navigation server 2D agent set avoidance enabled to true. Agent set avoidance callback. Here's another callback as we call this private function avoidance done. Agent set avoidance enabled to false. To avoid it, to turn it off. Set avoidance callback to clear it. Okay. Navigation script templates. The following sections provide script templates for nodes commonly used with navigation agents. Actor as node 3D. Actor as character body 3D. Actor as rigid body 3D. They don't have any 2D ones. Use navigation obstacles. Navigation obstacles can be used either as static or dynamic obstacles to affect avoidance controlled agents. When using statically, navigation obstacles constrain avoidance controlled agents outside or inside a polygon-defined area. When using dynamically, navigation obstacles push away avoidance controlled agents in a radius around them. 2D and 3D version navigation obstacles nodes are available. Navigation obstacles do not change or influence the pathfinder in any way. Navigation obstacles only affect the avoidance velocities of agents controlled by avoidance. Navigation obstacle is considered static when its vertices property is populated with an outline array of positions to form a polygon. Static obstacles act as hard do not cross boundaries for avoidance using agents, e.g. similar to physics collision but for avoidance. Static obstacles define their boundaries with an array of outline vertices, positions, and in case of 3D, with an additional height property. Static obstacles only work for agents that use 2D avoidance mode. Static obstacles defined through winding order of vertices if agents are pushed out or sucked in. Static obstacles cannot change their position. Static obstacles that are warped to another position cannot be predicted by agents. When the 2D avoidance is used in 3D, care about 3D. Dynamic obstacles, procedural obstacles. Yeah, so we're not going to be getting into this right now. Using navigation links. Navigation links are used to connect navigation mesh polygons for navigation region 2D and navigation region 3D, or for arbitrary distance for pathfinding. Navigation links are also used to consider movement shortcuts and pathfinding available through interacting with gameplay objects, e.g. ladders, jump pads, or teleports. Okay, I was kind of wondering about this, if they have a solution for when you, like when I wrap them right now, currently on the level, we wrap the screen. Does it count that in its pathfinding as like faster route? Because it just needs to wrap around. It seems like this is the way you would do it. Different navigation regions can connect their navigation messages without the need for navigation link as long as they are within navigation map edge connection margin and have compatible navigation layers. As soon as the distance becomes too large, building valid connections becomes a problem that navigation links can solve. See using navigation regions to learn more about the use of navigation regions. See connecting navigation meshes. Okay, probably don't need to dig into this yet. Navigation link script. Using navigation layers. Navigation layers are an optional feature to further control which navigation messages are considered in a path query and which regions can be connected. I need to make a navigation mesh. I wonder if that's what the grid is for. They work similar to how physics layers control collision between collision objects, or how visual layers control what is rendered. If two regions have not a single compatible layer, they will not be merged by the navigation server. See connecting navigation messages or meshes. Navigation debug tools. Enable navigation debug. Visible navigation. Navigation debug visualization are enabled by default inside the editor to visualize navigation messages in connection to runtime. In Godot, debug builds. The navigation debug can also be toggled through navigation server singletons from scripts. Debug navigation mesh polygons. If enable edge lines is enabled, the edges of navigation mesh polygons will be highlighted. If enable edge lines X-ray is also enabled, the edges of navigation meshes will be visible through geometry. Debug edge connections. Debug performance. Does not include pathfinding. Okay. Connecting navigation meshes. Different navigation meshes are automatically merged by the navigation server when at least two vertex positions of one edge exactly overlap. Exactly means exactly for the vertex position merge. Some small flow errors that happen quite regularly with imported meshes will prevent a successful vertex merge. Okay, so this is something else. Support different actor types. To support different actor types due to, e.g., their sizes, each type requires its own navigation map and navigation mesh baked with an appropriate agent radius and height. The same approach can be used to distinguish between, e.g., land, walking, swimming, and flying agents. Agents are exclusively defined by a radius and height value for baking navigation meshes, pathfinding, and avoidance. More complex shapes are not supported. Interesting. Navigation mesh standard size, small size, huge size. Set the radius, set the height. Get the root node to parse geometry for the baking. Navigation message source geometry data 3D. Map set active, navigation map standard. Start position, end position, corridor funnel. Path standard agent, small agent, map get path, navigation map standard, start position, end position, use corridor funnel. For different actor locomotions. That's cool. I think we're kind of out of navigation. Support different actors. Is this all under navigation? I guess it is. If you support different actor area access, a typical example for different area access in gameplay are doors that connect rooms with different navigation message and are not accessible by all actors all the time. Add a navigation region at the door position. Add an appropriate navigation mesh, the size of the door that can connect with the surrounding navigation messages in order to control access. Enable disable navigation layer bits so path queries that use the same navigation layer bits can find a path through the door navigation messages. Bitmask can act as the set of door keys or abilities, and only actors with at least one matching enabled bit layer in the pathfinding query will find a path through the region. Man, this is very cool. Technical, but cool. Optimizing performance, we're not there yet. And then it gets into networking. Cool. All right. Well, that's some good background. I'm probably going to have to find a tutorial. I could I could try adding a mesh grid or whatever it was called, and then add navigation actor. What is it called? So we have to add like a region. Navigation maps. What is a navigation map? We didn't read this one. Navigation map is an abstract navigation world on the navigation server agent. Navigation agent was I was trying to think of earlier. Identified by navigation server RID. A map can hold and connect a near infinite number of navigation regions with navigation meshes to build the traversal areas of a game world for pathfinding. A map can contain avoidance agents. Collision avoidance will be calculated based on the agent present in the map. Different navigation meshes are completely isolated from each other, but navigation regions and avoidance agents can switch between different maps. Default navigation maps. By default, Godot creates a navigation map for each world 2D of the root viewport. The 2D default navigation map RID can be obtained with get world 2D get navigation map from any node 2D inherited node. Create new navigation maps. Navigation regions. Navigation regions are the visual node representation of a region of the navigation map on the navigation server. Each navigation region node holds a resource of the navigation mesh data. Create a navigation region. Navigation meshes, 2D and 3D meshes in the navigation mesh are available. Navigation mesh only describes a traversable area for an agent center position. Any radius values on an agent may have are ignored. If you want pathfinding to account for an agent's collision size, you need to shrink the navigation mesh accordingly. Navigation works independently from other engine parts like rendering or physics. Navigation agent physics engine. Navigation meshes are the only things considered when doing pathfinding, e.g. visuals and collision shapes, for example, are completely ignored by the navigation system. If you need to take other data like visuals, for example, into account when doing pathfinding, you need to adapt your navigation meshes accordingly. The process of factoring in navigation restrictions and navigation meshes is commonly referred to as navigation mesh baking. Navigation mesh describes a surface that an agent can stand on safely with its center compared to physics shapes that describe outer collision bounds. If you experience clipping or collision problems while following navigation paths, always remember that you need to tell the navigation system what your intentions are through an appropriate navigation mesh. By itself, the navigation system will never know this is a tree, rock, wall, collision shape, or visual mesh, because it only knows that here I was told I can path safely because it is not on the navigation mesh. Navigation mesh baking can be done either by using navigation region 2D or using the navigation server 2D API directly. Baking navigation mesh with a navigation region baking. So are these the places you can't go? Navigation mesh baking is made more accessible with the navigation region node. When baking with the navigation region node, the individual passing baking. Oh, Wolfgang's here. What's up? Yeah, I'm just going into the docs on navigation, but it's more than I need to know. Okay, we already read about paths. Okay. I guess I should have started with the overview. Let's start with the overview. All right. Godot provides multiple objects, classes, and servers to facilitate grid-based or mesh-based navigation. Okay, so yeah, mesh-based is the regions and all that is an optional thing, so we could do grid-based. Pathfinder 2D, the following section provides a quick overview over all available navigation-related objects in Godot 2D scenes. Godot provides the following objects and classes for 2D navigation. So A-star 2D, we talked about that. Navigation Server 2D provides a powerful server API to find the shortest path between two positions on an area defined by a navigation mesh. That's it for using a mesh then, so we don't need this for a grid. Navigation Server is best suited for 2D real-time gameplay that does require actors to reach any possible position within a navigation mesh-defined area. Mesh-based navigation scales well with large game worlds, as a large area can often be defined with a single polygon when it would require many grid cells. See, that's kind of true if we have a big map, which we will. We really want to do grid based if we could just put one polygon, but maybe that's fine because we're limited to different regions because we have like a single square. You pathfind at that. Well, we also need to pathfind across them, right? Like if we tell an AI to go to a castle that's on another cell, or down from the current one, we need a way to do that. Navigation server holds different navigation maps that each consist of regions that holds navigation mesh data. Agents can be placed on a map for avoidance calculation. RIDs are used to reference internal maps, regions, agents when communicating with the server. Following navigation server RID types are available. Nav map RID reference to a specific navigation map that holds regions and agents. The map will attempt to join the navigation missions of the regions by proximity. The map will synchronize regions and agents each physics frame. Nav region RID reference to a specific navigation region that can hold navigation mesh data. The region can be enabled, disabled, or to use restricted with the navigation layer bitmask. Nav link RID reference to a specific navigation link that connects two navigation meshes positions over arbitrary distances. Nav agent RID reference to a specific avoidance agent. The avoidance is specified by a radius value. Nav obstacle RID reference to specific avoidance obstacles used to affect and constrain the avoidance velocity of agents. The following scene tree nodes are available as helpers to work with the navigation server 2D API. Navigation region 2D, a node that holds a navigation polygon resource that defines a navigation mesh for the navigation server 2D. The region can be enabled or disabled. The use and pathfinding can be further restricted through the navigation layers bitmask. The navigation server 2D will join the navigation meshes of regions by proximity for a combined navigation mesh. Navigation link 2D, we know what that does. Navigation agent 2D, helper node used to facilitate common navigation server 2D API calls for pathfinding and avoidance. Navigation obstacle 2D, we know what that is. The 2D navigation meshes are defined with the following resource: navigation polygon, a resource that holds 2D navigation mesh data. It provides polygon drawing tools to allow defining navigation areas inside the editor. The navigation region 2D node uses the resource to define its navigation area. The navigation server 2D uses the resource to update the navigation mesh of individual regions. The tile set editor creates and uses the resource internally when defining tile navigation areas. That is new. Is the map really that big though? Can it just go on a large mesh? The map is going to be, when you zoom out and you can see all the cells in the map overview, you're going to see, what is it? I don't know, 60 cells or something. I don't know. You could go look it up. But yeah, you're going to have like castle here, like row of like 10 cells at the top. And there's like two castles, one for the enemy, one for you. And then it goes down in a grid. And then each one of those actually needs to be navigated as well to like avoid, like say there was a wall here and you can't go off the right side of the screen, like you just have to stop here and go around or something. You need the pathfinding to find a way around here, but you also need pathfinding to know that in order to get to the castle, you need to walk 4 screens this way. So you need navigation kind of at both, right? We don't need to start with that. Obviously, we can start with just roaming around this. I was trying to think about what would be the smallest thing we could do to kind of prove out the system for the MVP. And I think if we add a second character, it's going to be the same art for now, but if we had a second character and we have it set, this might cause problems, but I was going to think like set its end. So like say I'm here and then the enemy with the AI is here. And we say, find a path from here to where I was over here. And then find the closest, path, node on that path, and then go towards it this frame. And then I move, and then we say, okay, now calculate a path to this new position from my new position. So you'd be updating the paths, the end position every single time, which is something they kind of said might look janky. So I don't know how it would work, but we could just basically start doing the AI that chases you around to fight you. Because when you're in the same cell as the enemy, you're supposed to fight to the death. You're not supposed to like run away or try to go find a castle on another cell. You're supposed to just stay in the cell, and the enemy kind of chases you around, right? So that's the AI we could work on today. What's up, Floppa? Lapa VR. So I wonder how quick we can do that. Just have something to show. So first off, okay. So first off, let's create a second character mesh here, just so we can have. We only got the queen. That's fine. We'll do the king later. Does it need all the player stuff though? Like the player script? Probably not. Let's start with copying the player, I guess. Oh, you're making the play area and then setting a viewport for the movement within. Making player setting a viewport for the movement within. I don't know if the viewport comes into play as far as AI is concerned. For the player movement, we're gonna want this. This is the viewport right now. Is the single screen because we want this kind of grid-like map where once I get to an edge, I go to the next grid on the map, and so you can only see one cell at a time, but there's a larger map. AI doesn't really need to know about a single view. What they need to know is, am I in the region of a castle? Because even if the player's not here, there's no viewport. You're not rendering it to the screen or anything. The enemy needs to like take over castles. And as far as when they're battling, they're both on the same screen. Yeah, there's a viewport for the player, but the enemy just needs to know I can't leave this cell until I kill the player. It doesn't really know that it's what a viewport is, but it needs to know like what a region, like what a cell is in the grid, if that makes sense. That's like a couple different mechanics interacting. I think for now we just literally want automatic movement is the basic thing we're trying to do here. So how do I do that? First off, we need let's make an enemy here. So probably do we need a scene for it? I feel like it's the same scene. So let's just reuse this scene if we can. This is the script that's on it. Okay, so let's go to our main scene and let's add another player, I guess. Don't want it nested. Okay, so player 2, we'll call this guy enemy for now. Enemy. I feel that looks like it's wrong. That's how you spell it. And this is gonna have everything the player normally has. Can we change the script though? We look at its scripts. Where's our scripts? Player GD. Okay, so this is gonna have the player script. Okay, maybe we don't want that then. Okay, let's undo that. Let's make a second scene, and we'll call this one enemy. Oops, that copy paste did not work. Copy here, paste here. It's weird, it doesn't want to actually copy the scene. Let's see, duplicate. Call this the enemy scene. Okay, and then on the enemy scene, we need to rename this to enemy. Keep the same sprite for now. You know, it'd be really cool if we could just like change it to red or something, just to distinguish it from the player. Obviously we have another sprite that we're going to add soon. I think our other dev is working on that though, so I don't want to overlap. Is there not a mesh, like is there like a color I could just put over the top? Let's see, animation. Nope. This is the sprite. Let's look at the sprite. Any ideas? What is this? Can I color this? Ooh, what if I duplicate it? What if we take this and we just make copy paste really doesn't work. Okay. We'll call this sprite queen red. And then how can we make this red real quick? Let's open it up. Don't really have any good image editing tools on my machine, but not file. Yeah, okay. Color sync utility, Chrome. Let's see. Can I quickly add? This is where we need MS Paint. I'm just kidding, that wouldn't work either. Let's see. Just color. Yes. That's what I wanted. All right. Highlights? No. What's a good tint? That's what I want. Tint. Can I add a special color tints? We don't have red eyedropper here. Let me select a color, please. No? Ooh, I like that green. Okay, blue. We'll rename it blue. Unless there's a red here. No. Can I get red? Can I get red? Who knows how these work? Anyone? Change the temperature. Give me a red temperature. Shapia. Ooh, close. Getting closer. You know, I don't want red. Enemies are red, right? Shadows. Ooh. Contrast. Oh, we got a purple. That's close. You're really close here. This is not important, but I'm having fun. So. Santiago, you wanna do this? That's kind of red. Ooh, its hair is red. What is going on there? All right, I'm going with this. If temperature is my best sand tint. All right, it's pink, but whatever. This is just temporary. Okay, so let's see if we can swap out the sprite now. Sprite. Change this. To create a new one. Viewport texture? No. Canvas texture? No. Animated. Who's this guy? Here we go. Load. No. No. How do you change it? Quick load. There we go. Boom. Cool. Now if we create one of these in the main scene, what does that look like? Just actually place it. Are they overlapping? They're overlapping. Nope. Where is it? Oh, is it because it's... Yep, it was behind the background. It's the player. Player 2. Oh, did I drag a player? Or did I just not rename something? Oh, I know what it is. I didn't save. It's an autosave. Save. There we go. Enemy. See if it calls an enemy now. There we go. Let's put you down here. Now here's the deal. It's got the player script. Is that going to crash? Crashed. Let's see. Yeah, crashed. Okay, so let's just remove the player script because that's going to confuse it. Thought that might happen. Nope. I want you to go away. Don't be here. Do you remove script? Delete. Oops, that's in the text editor. Don't want that. You... Oh, I need to do it here. There we go. And from here, I should be able to just remove this guy, right? Refresh. No. Now it's empty. That's a weird icon for remove. Who agrees? There's a script. What button would you press to remove a script? Might think, choose this. There we go, clear. Okay, whatever. I should have tried that. But still, that makes no sense. That this button, guess that's an undo icon? I don't know. I was looking for clear, and I guess that's clear. Did this change? I don't want to change this. Or do I? What are we looking at here? Why is this labeled enemy? Is this isn't this the player script? I want to save this scene, but I don't know what this I'm looking at. There's a script called enemy since when? Okay, let's try this again. Don't save. Okay, open up the enemy scene and then remove the player script. Now save. Okay, this is the scene. There we go. I don't know why it was in the script editor. Yeah, that's not enemy. What the heck? There's no script called enemy. Am I crazy? Player GD, but it's on the enemy scene. No sense. X mark. Cool. Now it shouldn't crash. Oh, did I save? Yeah, it must have. And I can walk around. Cool. Now we want an enemy script that's going to do the pathfinding. So I read a bunch about pathfinding, but didn't actually see how to get it started. Let's just we'll look it up if we have to, but I want to try something first. Is there a node we can add for, let's say, navigation? So we know this is for linking regions. We don't want that. Navigation agent. They said this is the optional thing, but it's good for noobs. I think they literally said newbies. Okay, so we add this. Let's add pathfinding. Desired path distance, targeted distance. So how do we set its target? I want its target to be the player, just to see if that works. Desired distance, sure. Pathfinding algorithm, A star. Include types. Avoidance. We don't need to care about avoidance yet. Process, mode, inherit, possible, okay. Thread group, don't care, don't care. We need a script. I wonder if we need a script to do this. Yeah, I'm not seeing anything that's like easy drag and drop to set like the target. So I'm pretty sure I read something that says you got to do it in scripts. Okay, let's make a new script. Ooh, script path name is valid. We'll create a new script. Having the script name be the same as a built-in type is usually not desired. Yeah, I don't want it to be called that. We'll call it enemy. I think we're using lowercase names. Renemy. Templates. Is it object or just node? Well, let's say node. I don't think it has an actual object yet. Technically, if we're going to do other stuff in the enemy scripts, it might be an object. So maybe this should just be like enemy navigation. Whatever. I don't want to overthink it at the moment. Okay. So we know we need to do something to set up the paths. And we know we need to do something on, not process, but like, what was it, like physics process? I think it was called physics process. This guy. Okay, but how do you set up? Let's see if we can find anything in docs, and then we'll go outside of the docs if we have to. Set up navigation, pathfinder. Navigation, 2D navigation, set up 2D scene. The follow step should set up basic minimum viable navigation. Yes. Setup for 2D scene. The following steps show the basic setup for minimal viable navigation in 2D. It uses the navigation server 2D and a navigation agent 2D for path movement. Add a navigation region 2D node to the scene. Okay, so this is using regions, but I'm down to try that. Click on the region mode and add a new navigation polygon process to the region mode. All right, should we go this route? Should we try regions, or should I look up the tutorial for grids? This hopefully is simple enough. Let's try it. But I don't think this is going to give me follow the player. This is going to just be like, here's how you can navigate around the area. Navigation measure defines the area where an actor can stand and move with its center. Leave enough margin between the navigation polygons. I really think we want grid, because the enemy can navigate anywhere. They don't have to follow a specific path. And we'll add obstacles later, but that's different than saying they can only walk on this, path. Yeah, I think we gotta look up grid. I don't think it's worth doing navigation, because we're gonna end up changing it later. Okay. 2D navigation grid example. 2D navigation overview, navigation grid based. Overview, set up 2D scene, navigation in 2D. Yeah, that's the one we just read. Baking navigation mesh, connect navigation meshes, 2D navigation debug. Your first 2D game, 2D meshes, using navigation maps, and 2D skeletons. I think I read all the docs there were on navigation grid, but let's see. I'm not even seeing it. Using tile sets. Using containers, using navigation maps, keyboard control. Is that a map? Where did we see the grid? What was it called? Navigation grid 2D or something like that. I spelled that wrong. Grid. A-star grid, that's what it was. Okay, so how can you use an A-star grid 2D? Is there any examples with using this? Navigation server 2D. Navigation server 2D in the server that handles navigation maps, regions, and agents. Navigation order. Okay, let's look up an example. Godot 2D grid. Three years ago. That's finding a 2D grid. Godot recipes. Setting up the grid. Thank you. This is what we want. The most important configuration decision is the size of the cells and the size of the grid itself. We'll use 6464 for the example. Add this code to a node 2D. Node 2D. Initialize grid. Initialize grid creates the grid size. A-star grid is a new A-star grid. Okay. Once you do that, then what? Okay, offset property, finally update, drawing the grid. For the purposes of this demo, we'll draw the grid on the screen in code. In-game application, you'll probably have a tile map or some other visual representation of the world. Here's some code to draw the grid. We don't need to do that, probably. Drawing the path. In order to find a path, we need to start an endpoint. So yeah, here we could calculate like the player's endpoint, maybe each frame. I don't know how performant that is though. Add a couple of lines in draw to show them. We can find the path between the 2 points using get point path. Here's how we can get the path. Adding obstacles, choosing heuristic. Cool. Yeah, that's piecing the stuff that we talked about earlier, reading the docs. But so the thing it adds is it actually shows me. I create the grid. I guess we did say this earlier. The question is, how do you get the player to use it? So they're drawing, but instead of drawing, we could move physically move the enemy. So let's see how they do the draw. So here, they're doing this in draw. And do they get the path? Oh, that's just the cells. Where do they get the path? Here, packed vector 2D array. A star grid get point path, start and end. So that gives you, so if this is your starting, that's your end. That gives you the path. But how do you actually move towards that path? That's what we want. Godot, enemy AI finding. How old is this guy? They create pathfinding for Godot 2D pathfinding in minutes 2 years ago.
Hey guys, in this video I'm going to be showing you how to set up and
reuse
find
RP.
games. So without further ado, let's jump right into this video. Now, I did recently do a video on how to do this for a 3D game, and if you want to check that video out, I'll leave a link somewhere on the screen. But to do this in 2D, we want to actually start by adding a level. So in this case, I just added a 2D scene,
Check.
which is a
Done.
2D, and I renamed it to level 1. As a child of the level 1, I'm adding the navigation 2D node.
Okay,
Child
so
of the
they put it
navigation.
on the level. Okay, I already messed up then, guys. Let's delete this. I did my job and I read the docs and it still didn't give me enough details. Here we go. Save that guy, go back to main. What is the level in this case? Is the texture rect background or is it just the main scene? I think this is the main scene. Okay, let's just do it. Navigation, agent, 2D? Agent, right? Or is it server? Oh no, he did something else. I thought it was agent. Okay, maybe agent does go on the enemy. What did he add? He just added navigation. What did he add? It was just called navigation 2D. Wasn't a region, wasn't an agent, wasn't a link. Is this old? Is he not in Godot 4? Maybe that's the short name. What did he search for? Yeah, under node 2D. Node 2D. It doesn't exist. I think, what are these? One of these. Okay, so I think this is old. I mean, it is 3 years ago. Godot 4. Should we use AI, guys? This is Gemini. It's probably really bad. Let's see. Here's some steps to set up minimal viable navigation in 2D. That's exactly what I'm trying to do. Thank you. Create a region node. No. Already no. Maybe not. Maybe we need a region even for the grid. Maybe I'm just wrong there. Add a navigation polygon resource. I feel like there's a way to do it with the grid. I'm being stubborn here, but some tutorials.
Animation and more in-depth states for how the enemies will react in your world. But either way, let's just get right into it. So if you haven't watched the previous video, I would recommend watching that, as it will help you set up everything that I currently have.
This is part 2 avoidance. And this is 9 months ago, so okay. Maybe this guy's open. Notice some parts of this room might not work as expected due to release of Godot 4.1. You can find more about this in this documentation. I'm trying to implement my own context-based steering. Alright, this guy might have something. Let's look. Polyphonic audio player. Yeah, this guy's got a lot of tutorials. Sick. Yes, code in Godot. Game dev tips. I just saw it. Pathfinding. For 1.
What's up, guys? In this video,
9 months ago.
to make a two-dimensional navigation system in Godot. This will kind of be an extension to the previous video I made.
These guys should chase him.
On how to create like an aggro system and return system for the enemies. So as you can see here, I have a really basic world setup. We have a tile map with collisions and navigation on the floor. And if I go to these enemies, they will end up chasing me until I leave the aggro range C, and then they will return back to this.
Oh, cool. Don't need all that, but we could definitely use the
here, and
I'm gonna use in aggro mode.
I'm going to go up to the top left. We're going to just add some basic things. So we need a world scene. We're going to save this in our world folder. And then we're going to add a couple nodes in here. The first one is going to be a camera. The second one is going to be a tile map. And then the third one, we're going to need this player, which we'll create in a second. Now for the camera, I just want to expand this a bit. So
let's skip ahead a bit. We have this.
So this will not work.
So we need to do this tile map part, Santiago. I was thinking maybe if you can get on camera, you can,
and then if we select a tile,
you can run it, and I can guide you, or like we can do a pairing. You create the tile map. But let me finish this AI stuff first. I don't know how much time you got, but I want to just do a really simple nav. So he added area 2D. That's probably what we want to do.
Aggro activator. So we're gonna make.
Oh, this is for activating the aggro when you get in a certain radius. We don't really need that.
We'll just give it a circle. We'll make it about as big as the player, and then we'll go into the collision for 2D and make sure it's on.
Yeah, so we just want whatever he does after they interact.
Anything. Now we need to add a script to this player, so we're going to click the new script icon, open this up, and I'm just going to copy my player script. And if you want to here and copy code here, this is the entire script. Now, after you've done that or you run the game, you need to set up the input actions for the movement. So we just have some basic ones. We're going to go into project settings under the input map. We'll make a new action called
skip this.
Player movement working. So here, this will act as a navigation folder for all of our navigation components.
Where did you put this?
The
in the player scene.
We're going to make enemy pathfinding. So we're going to make a new scene here. It's also going to be a character body 2D, and we need to give it a collision shape for the world collisions.
This is his enemy, right?
New circle shape for this, and we also need to set up a sprite again. Drag this behind the collision shape so we can see how big it is, and we'll assign the enemy texture to this sprite. Increase the size of this a bit, and then we need to set up some basic nodes for how the navigation will work. So we're going to make a new node here. This will act as a navigation folder for all of our navigation components. And inside of here, we want to add a navigation agent 2D.
I wasn't wrong.
Add a timer node. I'm going to
added more to it.
Recalculate timer, and we're going to set it.
Okay, so he's using a timer so you're not constantly redrawing. Remember I said it's going to be a little weird if you're setting the path end to the player, saying, hey, find a path to this player. Oh, by the way, it's the next frame the player's moved. So like there's a timing to it. Let's see what he's using the timer for.
To auto start, and we're going to set the wait time to 0.1. We also want to rename this to enemy and save it inside of an enemy.
I even got the name right, guys.
Inside of the character
watch.
top, we need to set up a couple things. So first off, in the collision tab, obviously make sure it's on the enemy layer, and it's masking all three of the first layers. And then for the motion,
we might need to set up this collision so they don't overlap. But
and we'll set the wall minimum slide angle.
Not worried about that right now.
This will allow the enemy to basically move along objects, and it will slide around corners and walls.
Having objects yet. Keep it really simple. Our MVP is even more MVP than his.
And lastly, we're going to add 2 different area 2Ds. We'll actually put a folder for these as well. So make a new node 2D. We're going to set this to aggro. And then inside of here, we need an area 2D, and we need a collision shape for this. And the collision shape is a circle. We'll make this one.
Yeah, we don't need this part.
This will be the area that you have to enter in order to activate the enemy chasing you. And then we'll just duplicate this with Control D. And this circle will be quite a bit bigger. This will be.
We might want something like this when we get into
Stop following you.
when we get into actual battling. Like we might want like if player is in with this certain radius, use your sword as the enemy. Enemy uses his sword to attack. If it's in this radius, use your, sorcery powers or whatever, right? Your magic. Or some kind of state machine based on distance, and I don't know what else we'd want to consider. Health, like if the enemy's health's low, maybe certain like maybe there's a coward enemy character that runs away or something when it's like low on health. Who knows? We might use these kind of area things as part of the setting up of the actual AI states. But for now, we just want simple aggro all the time.
So this first one we'll name aggro range, and the second one will be D aggro range. And I also messed up these two shapes are currently using the same shape resource. So we need to just, in one of these, make a new circle shape for it. So now our aggro range is about here, color to red, and then for our de-aggro range, it's going to be quite a bit bigger, and so you need to exit in order for the enemies to stop chasing you. Okay, and then the last thing we want to do is inside of the navigation agent,
Agreed. That's the best approach.
and enable it. And this will just show us a visual representation of the path which the enemies are currently using for their pathfinding. And we now have our entire scene set up, so we can get into the programming.
This is what we want. Okay.
We're going to add a new script here.
New script.
And I'm going to walk you through how the code works. So at the
All right,
top,
let me add the two nodes under navigation agent 2D and recalculate timer, which I'm guessing we're going to need, unless it's related to aggro, but I don't think it is. I think it's when he's recalculating the path to the player. All right, let's try that. So on the enemy scene, save whatever we got. On the enemy scene, we're going to create a new node 2D folder, basically, that he calls navigation. And then inside that, we're going to add a navigation agent and a timer. And what did he call the timer? Recalculate timer? Recalculate timer. And and I don't know if I think he did auto start or something, right? Auto start, yeah. Did he set a timer on a time? Well, we'll come back to that.
this will be called speed, and we'll set it equal to 50 for now. We next need another export variable. This one will be called nav agent, and we'll just make it a type, which will be navigation agent 2D.
Makes sense.
A variable for the target node. This will be the node that the enemy is currently chasing, so we'll set it to null for now. And then we need one more variable, which should be the home position, and we'll set it equal to a
This one's not.
0 to
This
start.
one is not exported. Our target node could probably be exported because it's always going to be chasing the player. He's probably not exporting it here because he wants to set it based on the collision. So when the player is in that aggro collision range or whatever, he's going to set the target, I think. But we can export target node and set it to the player. So let's go ahead and do that now. So speed, nav agent, target node, home position, we can probably come back to. So he made a new script. What did he name his script? Named enemy? I don't see a script saved. Am I crazy? We didn't save it yet. Okay. New script. I think we should call this. No, I said enemy earlier. Oh, we already have that actually. Screw it. Let's just use enemy then. Okay. Let's export the things. All right. Remind me, what did he do? He exported a var, nav agent, I think, right? And that's a navigation agent 2D. What else? Speed. There was like a speed. Yes. What's the type? Number? Is number a type? Int? What are the types in GD scripts? It must be int. And did he set it by default? I can't remember. I remember seeing 50. Yep, 50. Speed. Okay, he put speed first, but whatever. Does this work in Godot? It does. Nice. But I want both. So. Okay. I guess it doesn't matter. Target node null. We want to set that. Home position. Is that that's probably a float, right? What was it? Oh, vector 2D. Yeah, that makes more sense. No. Dot 2D. Vector 2.0. Done. The memory of a goldfish. All right. And then yeah, I do want to export this one. This will be the target node. And is it any node? I think it could probably be an. I don't know if you can type it to the player. Let's just say node 2D for now. He didn't even give it a type.
Assign this navigation agent. So click on the enemy up here.
Oh. Okay, so this is not the type. He actually set it to 0. So the type is vector 2D. I knew something was weird there. 2. Okay.
Navigation agent property. We'll just select our navigation agent 2D here and make sure that is all set up. And now we need to initiate ready function here. So we'll write function underscore ready. And the first thing we want to do is set up our home position, which is where the enemy will return to when there's nothing to follow.
We don't need that.
Equals self dot global position. We also want to.
We can do that though. It's fine for now. Oh, he called it POS, didn't he? Yeah, I'm not a huge fan of acronyms. We're going to keep it. Equals self dot. Was it current position? Or just position? Global position. Santiago, you're on YouTube, huh? YouTube's got a delay for some reason. Twitch does not. All right.
Okay. I'll set up a couple properties in the navigation agent, which will be the distance it considers complete when it stops calculating the path. So I normally just like to set these up. So we're going to say navigation agent dot path desired distance, and we'll set it equal to 4. And then we'll also say navigation agent dot target desired distance, and we'll set this to 4 as well. Next up, we need to do the physics process function. So we'll write function underscore physics process delta. We can just put an underscore before the delta for now. And then we're going to first check if the navigation is finished. If it is, then we're just going to return right away, and this will prevent any jittering. So we'll say if navigation agent dot is navigation finished, then we're going to return. And then we need to make a new variable here called axis. This will be kind of the direction that the enemy will be moving. And we'll set it equal to local. And inside of here we'll put navigation agent dot get next path position. And then after we get this, we'll just normalize the whole thing. And then next up we set up the velocity. So we'll say velocity equals axis, and then we'll multiply this by our speed. And then the last thing we need to do in the physics process is just move and slide the enemy.
Move and slide.
Now, before we set up any of our signals, we just need to make one more function, and this one will be called recalc path. And this will just recalculate the current path, which we need to move along. So the way I'm going to set this up is
timer.
Check if we have a target node that we're trying to follow. If we do, we'll calculate the path. If we don't, then we'll calculate a path back to the home position. So how we do that is really simple. We'll just say target node, then navigation agents dot target position equal to target node dot global position, and then we say else navigation agents dot target position equals home position, and that's the bulk of our script setup.
Okay, we don't need that. All right, we'll do the physics process first. He's saying if it's finished navigation, do nothing, just return. Get the access from get next path position, calculate the velocity, axis times speed, move and slide. Okay. If nav agent dot finished, close some of these windows. Do ifs have colons? They do. Oh, it's a function too. Okay. All right. What's it mad about? Name, navigation finished, called as a function, but as a signal. Didn't he call it as a function? Oh, is navigation finished? Cool. What was the next one? Axis. Var axis equals local to local from global, right? To local, and then it's the position, or it's to get the next path, right? So you say nav agent dot get next path position, and then he normalized it. Did I miss anything? And then he used this to calculate velocity, or set the velocity equals axis times speed. And then he actually did the move and slide, move and then slide, something like that. To local, get next path position, normalized. To local not found. Oh, did they change that? Remember he had a note about something changed? Some parts of the order might not work as expected. Back. Yeah, so I think this might have changed. Is it deprecated, or did I just typo this? Let's see. That looks right. That looks right. Yeah, this is not a thing. To local's not a thing. Godot for to local. 1 year ago. It's a method of self. So it's really short for self.to. Did I not put this on a node 2D? Like, why is this? How is this not a function? To local. Takes a global point. Maybe I just passed it the wrong thing. Get next path position. Is that the wrong thing? Get next path position. What does that return? A vector 2. And what does the doc expect? Global point vector 2. Doesn't say anything about being deprecated, right? What am I missing here? I got a 2 string. Oh, maybe this didn't close out properly. My tab's wrong or something stupid like that. I do it up here, does it work? R A equals to local. See, now it seems like it. Nope, yeah, that's not a thing. Am I crazy? Why doesn't this work? Not found in base self. Let's double check. What's the type here? Doesn't say. Is it because it's not on anything yet? Now, why would it know that? The script. To local, not found in base self. To local. I didn't extend any node in my script. Did he do that? Where does this say? Extends character body 2D. Wah, wah. There we go. There we go. All right. Cool. Physics process. If nav agent is finished, return. Otherwise, calculate axis. Normalize it. Velocity equals axis times speed. Move and slide. Recalc path if target node. Oh, this is the function the timer calls. But this just says if you have a node, calculate target position. I guess we need to do that. We just don't need the if target node problem. Our part. Nav agent dot target position equals. It calculates, because why abbreviate, path. And then in here we say the node agent that needs node agent dot target expected indent. Node agent dot where is it not indented? Yo. What's up, F2000 ohm foe? Node agent. Nav agent. Oh my god. You think it would have said name's wrong? That's not a thing. Nav agent dot target position. Is that one? Target position, yeah, equals target node global position. Equals. What am I doing? I am doing the most basic, smallest possible step you could do to add navigation to our 2D game. Nav agent equals target node dot global position. Okay, and we don't need anything else, right? That was all we really need. This guy's I'm using this tutorial from the genius Quibble. Subscribe today. I will. Thumbs up. Okay. Great. Now we just need to actually save this. We need to put it on our enemy. C++ or Java? Neither. This is actually a scripting language built into Godot. Very Python-like, I would say. It's like tab-based like Python. Uses snake casing function names. Variables. It's very simple though. Okay. Back in our level. Main. I lost my window. Come back. Script. What do you prefer then? Normally my favorite language is Kotlin, which runs on the Java JVM, but also do some web stuff and TypeScript. Used to do C# back in the day. I haven't touched in a while though. A lot of Java back in the day. Python when I have to do data stuff. I like it for local scripts too. Depends on the job, I guess. I've recently did some Elixir. That was wild. You ever hear of Elixir? Or not Elixirs. What is it called? Oh my god. It was a couple weeks ago and I already forgot. It runs on. What does it run on again? Erlang. It runs on the Erlang VM. I guess it is called Elixir, but the Erlang VM is like meant for like really performant backends, especially with like sockets. Didn't love the language though. The types were so broken. But I would do it over Rails, Ruby and Rails, because Elixir and Phoenix is much more modern, I think. It's got something called Live View, which is lets you basically calculate the front end for a website on the back end, and then do the UI, like update the UI and stuff on the front end live if you want. Okay, where was I? This is the wrong script. Where we should be. How did I lose my left hand tab thingy? Oh, because I did this maximum. Okay, never mind. We're in the main. We're on the enemy. We don't want to be here. We want to be in the scene for the enemy. I am on the scene for the enemy now. We want to make sure the enemy has a script. Enemy does have a script. We're good there. Now we need to set the speed. It's already set. Set the nav agent. We got that. And set the target node. Target node's going to be the player who is not in this scene. So can we do that from main? That might not be possible. Oh, I didn't save it. Okay, so if I save this, then go back to main, it has the nav agent but doesn't have the target. So target node now can be the player. Beautiful. You said no what? Never heard of it? Yeah, it's crazy, man. Once you get into like different tech communities, people just love their frameworks and their tools, and it's crazy how many people like still use things like Ruby on Rails, and then which is like if you zoom out, is such a minor part of web development. Like people hate, most people think of it, oh, that's stupid, it's old tech, whatever, nobody's gonna use that. But there's like some pocket communities that just love it. They go to conferences and stuff, and they just anyways, that's a huge thing. And then to think there's even a more niche product, which is Elixir, which grew out of Ruby on Rails and Phoenix. It's like insane. And then there's like really, like the mainstream obviously is Node and TypeScript. What am I using now? For this project, I'm just using a scripting language called Godot script or GD script. My current gig at work, I'm using Kotlin because I'm doing Android stuff. I just got done using that Elixir thing, and then right before that I was using TypeScript, doing some Python in between when doing some AI stuff. Let's see. What were we doing? Okay, so we added the player. Great. All that seems fine. Does it blow up? Test it live. Test it live. It does blow up. Great. What was the error? Script inherits from native character body 2D, so it can't be assigned to an object or type area 2D. I think it's because I accidentally put the script on the scene or something weird earlier. Yeah, it's here, so it shouldn't be here. It should be on the... Actually, where was the script? No, this is where you put the script, right? But this might not be a 2D character body. Is that the problem? Can I change this? Attach script, rename, change type. Yeah, so this should have been... Was this area 2D? I don't know. Let's make it a character. I don't know why it's area 2D. Cool. All right, rerun. Still crashed? Didn't save, maybe? No, is navigation finished on a null value? Okay. Well, let's see why that might be the case. Let me rerun just to make sure. Yeah, okay. On a null value is navigation. We call is navigation finished on navagent. Navagent should never be null because we set it in the level. Actually, we set it in the scene for enemy. Nope, it got unset somehow. Weird. Try to save again. Run again. It's been when I removed the script. Okay, good. All right, so here we are walking around. It's too much for me. I would love to keep using GameMaker 1. Now I'm doing Unreal because we've got to do something. What's too much for you? Okay, so this is the enemy, the pink one. It's supposed to be red, but whatever. It's in it. Yeah, I really wanted to learn Unreal, and I started using it for this game. And it just, I only get like an hour. No, that's not true. When I do work on this on stream, I spend like 6 hours, but I really don't spend that much time working on this game. I should spend more, but when I do, I spend most of it learning the new tools and don't actually build the game. And even though this is like, how long have I 2 hours now? Yeah, 2 hours. And we haven't done much, mostly read the docs. We still got way farther than I would have in Unreal in the same 2 hours, in my experience. So that's why I like this game engine. It's much more straightforward, I think. For what I'm trying to build, this 2D game, don't need Unreal. It's overkill. And anyways, okay. All right, we did that. We don't have a path yet, though. Like, where does that part come in? Or we don't have the grid. Where's all that grid?
Just to get everything working.
Oh, I didn't do this, right? Path desired distance, home position. Did I do that? I feel like I didn't do that part. Enemy on ready. I did the home position, but I didn't do nav agent. I'm not even using home position, so I should get rid of that. Too many options. Took me a while just to get the camera straight for a 2-second game in Unreal, but after that thing started moving along. Yeah, that's, if you watch my earlier streams on Unreal, it was a lot of camera stuff. Yeah, if you can do master Unreal, that's for sure the best thing to do. Like, those skills are going to transfer anywhere. You can definitely use that. So I don't knock that at all. Okay. Path desired distance. Path desired distance. Path desired distance. Can't spell. Path desired. And the other one was, equals 4. Don't know if that's going to work for our map, because our map might be a little bigger. Start with 4, though. And then I forget what the other one was. It wasn't path. It was target desired distance. Who else is on the stream? Someone else is watching. I was going to ask questions to the other guy, but I think he left. Alright. I don't know if that's going to even do anything. Cool. Didn't crash. That's all I need to know. Alright, how do we need the timer to recalculate path.
Inside of the node tab on the right, we're going to connect the timeout signal to the enemy script. And then inside of the aggro...
Connect timeout to enemy script. Okay, so that way it knows to call recalculate path. Well, we still have to set that up somehow. But let's do that. That's somewhere in the enemy scene under navigation. We need to set this up. I didn't see what he actually clicked. Did you guys see it? How did he connect it to the player? Or to the enemy? I missed that. He clicked something. One shot, auto, node. Parents, priority thread, enter. Let's just watch it again.
So the first thing I want to do is go into the timer node we have here inside of the node tab on the
Node tab. I missed that. There we go. Timeout. And then he set it to enemy. Oh shoot, was it enemy or enemy script?
The timeout signal to the enemy script. And then inside of the aggro range, keep in mind this is where you have to enter.
We don't need this part.
Activate the enemy chasing you. So inside of this one, we're going to connect the area entered signal. And then inside of the de-aggro range, which will be where you have to exit for the enemy to stop chasing you, we're going to set up the area exited signal.
Don't care about it.
We're just going to connect that to the script as well. Now, inside of the timer timeout, we're going to make sure to call recalculate path. And this will recalculate
On recalculate timer timeout. Where is he now? Recalc path on recalculate timer timeout. Where did he get that name? Oh, when I hooked it up, it created it. Here it is. Boop, boop. Cool. Yeah, that's the one thing about Godot scripts, and why I chose to use it over the C# integration, is there's a bit of magic, which I know it's not great because it's hard to remember and explain, but there's magic here where when I click this button and I assigned it to the enemy, now my enemy script has a new function. I did not create that function, and if I were to create this function manually, it would not actually be hooked up properly. This little thing indicated in the UI, that would not happen if I just like wrote this function manually. So how you actually connect the two objects, magical, right? Like if you look at the code that's changing in the background, like if I save this and pull up GitHub, show you a visual representation of it. There's stuff that's changing that's not actually the code. Like, look at this stuff. The scene actually has some code behind it. Look at this, like a bunch of properties, right? This is what you're seeing in the UI. And so something in here that's changing is this, right? So this is represented in code somewhere, but I don't really have control over that magic. I just know that once this connects, and there's supposed to even be an icon, I believe. Sometimes an icon will show up here showing a connection, right? I click this, does it open? It's already open. Let me see. If I go back to the timer and then click this, does it open? Oh, see, it's already open, but whatever. I don't know if I explained that very well, but the point is there's some magic under the hood. And so you don't get that with C#. You would have had to like hook it up some other way. So on one hand, it makes, these are called signals, by the way, it makes signals easy, like communicating between objects easy because it just works, but it also makes it magical because you don't know how it worked. You had to do it through the UI and then all of a sudden it magically worked. Weird, I know. But anyways, we want to call recalculate, so we'll do that. Do we need to pass anything? No, we don't. Okay.
Every 0.1 seconds in this case.
Okay, the timer was set to 0.1. That I don't think I did. Let's check. Yeah, it's 1 second, so that'd be really slow. And I think the reason for this timer is it's solving the problem that I kind of mentioned before, which is you can't calculate the path every single frame. Could. As the player's moving and you want to calculate based on the target being the player, you would be recalculating the path every frame, and you would also be moving towards the next logical step towards there using the Haystar algorithm or whatever. So calculating that would be really janky if you're constantly moving the target. And so this 0.1 seconds, I think, helps with that. We'll see. Okay, didn't actually move. So probably missing something else.
You can change this if you want. You can make it happen every frame if you like. I
wonder if I didn't save the timer change.
Performance and the amount of enemies or whatever you have in the pathfinding, you'll kind of want to adapt this to that. But for this system, this will work just fine, especially since it can calculate the path if there is a target that it's trying to calculate to. Next up, on the aggro range entered, we want to assign a target node as the area.
So we don't need that because we're doing it by default, unless it's already like changed or like unset it like we saw before, but I don't think so because it probably would crash. So look at enemy, it has the player set as the target node. Okay, so we already have that.
The area we entered, and say dot owner, and this will get to the scene owner of this area, which in this case, if we interacted with the players, area 2D here. It would get the main player scene, and then it would set our target to be the position.
Yeah, we don't need this. Cool.
And lastly, on the de-aggro range area, we want to basically null out the target. So we want to do that if the current
You
target
skip ahead on the website.
So we'll say
On my phone, I just double tap over here.
equals.
Doesn't really work here.
Then we're just going to say target node equal.
Skip ahead.
Now, if you'd want to expand this a bit, where you have multiple different
I could click here, but
and then you could follow in the world, you might want to consider adding a list, and then basically what you do is whenever you interact with a new area, you'd insert that area at the start of the list, and then you'd always be targeting the first item in the list, and then when
that's cool.
you just remove that one item from the list and
We won't need that in our game. There's only ever one
I'd say that's a
player, one and enemy in the same scene at a time.
of how you'd handle it if you
Interesting.
do something like that. But we're just going to use this system for this tutorial since that's a bit out of the scope here. Also, I did want to mention that if you wanted to animate your enemies, you could just set up a basic blend space 2D, and then you could
shoot.
on the blend space, and then all you'd have to do is use this axis variable, which would be the direction that your enemy is
We need
moving,
that.
and then you can link this axis
We'll need that, but
directly to
we can
the
probably do that
blend
later.
space and animate them accordingly. I'm not going to go into depth with that in this video.
Yeah, we can figure that out later.
Scope of this tutorial. If you do want to learn how to set up a blend space for animations, I'll
I'm curious why this didn't work. I think he's done.
feature here.
I don't think we missed any steps.
For that. But with that being said, this is the entire system we'll need for the enemy. So we can go back into our main world scene here, and inside of the 2D view, we're
So what are we missing?
a couple enemies
Other
here.
than the aggro stuff.
Corner, and then duplicate it with Control D and move it over here. I want to go into debug at the top. And
Oh, is it the...
and then we're going to run this
Are
again.
they not on the same navigation area?
I forgot to mention if
Mask or whatever it was called?
nothing happens.
Oh, it didn't work. Okay, I'm not crazy.
Area 2D over here inside of the enemy. These aren't actually looking for the correct layer. So
This is with collision, but still, something like that maybe?
to be the player, and we want to set that up for both of these. So
Okay, I don't have the collision, but I wonder if that's still messing with the navigation calculation somehow.
we can go into the range.
Let me see. That's only for collision though, so that doesn't quite make sense for our problem. But let's see. Let's put them on the same one anyway. Layer. We don't have layers. How does he do that? Edit layer names. Oh. Layer. Does that work? Layer. Okay, so put that on the player. I wonder if you need mask and... Whatever. And then do the same thing on enemy. Again, this is for collision, so I don't think it matters. Oh, it's already there. What? That's weird. Oh, it just wasn't named. They're there by default, maybe? Sure, that's not it. Okay, that doesn't matter. Navigation layers. I think we read about that. There's some navigation... Nav agent, filter properties, motion... Motion grounded. Oh, that's another thing to look at. Maybe the way it does motion is weird. Gravity disabled. Stop on slope. Lock on wall. Like these things. Probably don't want those. At least not right now. Moving platform. Don't know about that. Priority, disable mode, collision object 2D, transform. What am I missing, Santiago? Why isn't this guy moving? Target node, he's got a speed. Is this the wrong target? No, that looks right. Motion. Let's check if the enemy's seen. Let's see if this has like a plane or something. Pathfinding navigation layers. That's what I was looking for. Layer 1. A star. I still don't see. There's no way to set up a navigation layer on the enemy or on the player though, right? Like that's not a thing. Okay, why don't we put some debug in our player script to see if that's even calling this recalculate path. I forgot how they log. Is it just log? No, it's probably like write, print. It's print, I think. I'll just say timeout. And this one will say recalculate. Okay, so it's actually calling this. Is this set up wrong? Weird here. Target node.global position. I guess we could print that too. Save that, run that. Back. Okay, so it has a position. We missing? Is it the move and slide not doing what we think it should? Moves the body based on velocity. If the body collides with another, it will slide along the other body rather than stop immediately. If the other body is a character body 2D or a rigid body 2D, will also be affected by the motion. Modifies velocity if slide collision occurred. Why isn't it actually moving? Why isn't it doing what we want? All right, so we set a velocity. Let's see what we set the velocity to. Oh, it was already updating. Cool. Yeah, velocity is not set. Velocity is wrong. What does this axis come out to? I guess it must be 0. Either that or the speed's still 0 somehow, but I don't think so because it's hardcoded to 50. So let's print that then. I think you can do multiple on these prints. It's kind of nice. Okay, speed set, axis is not. Okay, so axis is not being calculated properly. Get next path. Get next path is probably not doing anything. We must have missed a step, right? Kids are chanting songs over here. Hard to focus. Yeah, so I wonder if it's something to do with this distance. What does path desired distance mean? The distance threshold before a path point is considered to be reached. Maybe they're too close together. Maybe it already thinks it reached there. Let's move them away from each other. Guess I can't see it. Hey, it's working. It's creating a path at least. I can't see though. You move? Did it move? I can't tell. It's creating a path. If I get close, does it stop? Still has the same. Not moving. Why is it? No, at the bottom. What is going on? Oops. Get out of the docs. Go here. Okay. Physics process. I wonder if this being triggered? No, because we're getting here. What could it be? So now it should, now that it has this, it should actually have a velocity, right? We'll say print velocity axis. Zeros. Oh, I wonder if the two local, because I only printed this. I wonder if the two locals messing it up or the normalize is messing it up. Okay, so let's try this. New comment in this language, probably pound. Oops, not what I wanted. I know you got some shortcuts. This will be, we'll start here. Do this one first. And then let's do normalize. I forgot to print it, didn't I? No, I didn't. I didn't hit print. Oh, I did. 0, 0. Okay, so the two locals breaking it. Is that what we found out? Nope. So, what's up with two local? Two locals coming out to 0, 0. Why? It transforms the provided local position into a position in global coordinate space. The input is expected to be local relative to the node 2D it is called on. E.g., applying this method to the positions of child nodes will correctly transform their positions into global coordinate space. But applying it to a node's own position will give an incorrect result, as it will incorporate the node's own transformation into the globes. Do we need this two local? I think we do, but why is this not working? Oh, this might be the thing that changed. I keep saying that, but he said something's broke, right? I'm still coming out to 0. It's changing, so is he moving? Can't be, right? Why would the... Oh, he moved. Where is it? Oh, it's probably way off the map. Because it's not the local. Yeah. Okay, so we got it to move, but it's like way off the map because it's not localized. Why does two local return 0? Any thoughts? Any thoughts? Godot to local returning 0, 0. According to Godot issue, the function animation tree to get player position returns 0 when called during playback of an animation that is set to loop. Is that something to do with our animation? I don't think so. This is get next path, whatever. To local without using node. Global position returning local instead. No. Resetting the world. There's a to global is funky. Get current play position. Matrices. Godot engine. Input Godot engine documentation against Godot. Any thoughts? This is weird. Probably something dumb. We're saying nav agent get next. We know we have a coordinate, and these must be in global. So global versus local. What are we talking about here? Let's understand this a little better. I'm not going to use your AI. I'm going to use ChatGPT. Let's do some understanding. Why don't we? Okay. Let's see. In Godot 4, why is calling to local on required? Hold on here. Okay, it says often requiring convert global vision provided by to the local space of the object that is navigating. This is particularly important when working with scenes where the navigation logic is encapsulated within a moving or otherwise transformable entity, such as a character or vehicle that is parented to another moving object or has its own set of transformations applied. The get next path position function typically returns a position in global space because pathfinding calculations are done in relation to the entire game world, which also for a consistent point of reference. However, when applying this position to a particular object, you need to consider the object's current position, rotation, scale within the world. That's where toLocal comes in. It transforms the global position back into the object's local coordinate system, taking into account the object's own transformations. This process ensures that navigation and movement are accurately applied relative to the object's current state and position in the world without converting to local space. Movements could appear disjointed, incorrect, or out of sync with the object's intended path or orientation, especially in complex scenes or when dealing with hierarchical parent-child relations within the scene tree. In Godot 4, the navigation systems and methods used may be evolved or changed to previous version. Okay. Why would calling to local return every time, even when the global position is no. Okay, I thought that was 4 numbers for a second. Might be an issue with the setup of context in which toLocal is being used. Here are several potential reasons for this behavior. Identity transform. If the object's global transform matches the identity transform, i.e. no translation, rotation, or scaling has been applied, calling toLocal with a global position could result in 0, 0. If the object itself is positioned at the global origin, it is not positioned there, or if the calculation results in a position that effectively becomes the local origin due to rounding or position errors. Parent-child relationship. If the object for which you're calling toLocal is deeply nested within a hierarchy where an ancestor has a transformation that effectively negates the global position when converted to local space, this could also result in 0, 0. This might happen if the parent has the exact inverse transformation. Nope. Improper usage of context. Ensure that you're calling toLocal on the current object and that the object has been properly initialized and added to the scene tree with its transformations applied. Calling toLocal on an object that hasn't been properly set up. It's not on the object, though. Misunderstanding of global versus local space. There could be a misunderstanding of how global and local spaces are computed, especially if the object's current position, global position, is very close to exactly at the point you're trying to convert to local space. So I wonder if that's what it is. I wonder if this desired distance thing is like bad scale. I feel like we need to go lower, or maybe higher. Let's start higher first. See if this does anything. No, still 0, 0. Okay, let's go lower. This might be part of what changed or something like that. I feel like the one thing that we're missing, we never set up the grid. I guess it's just using the entire map as a grid. Navigate. And the fact that it's finding coordinates, like the next path, and it's moving there apparently, right? It's just not. This is moving by 1. I bet if I set this to 100, it would be more. You'd see jumps of 100 or something like that, right? I can't tell. Let's try 1,000. Just like going in circles. Mm-hmm. This is with me removing the 2 local, because 2 local is going to always set it to 0, 0. If I did the 2 local, there's not like a stupid typo in here somewhere. Yeah, so it will never move. Now it's not moving. It's like, hey, I'm here in global space, or the next step I need to go to is here in global space. What is it in local space? It's 0, 0. Okay, I'm not going to move that. It's like you're already where you're supposed to be. Oh, I wonder if the target node is like set to itself or something stupid. That would do it, right? Target position equals target node dot global position. Should this be local? Target position equals target node global position, and target node. That would do it if I set the wrong thing, but I'm pretty certain I didn't. Let's check. Enemy player. Target node is player. What if I set it to myself? I want to see if that changes anything. Still 0. Okay, what if we set it to this is something that's different, right? Like this is not using the area 2D. Maybe we need to do player dot like get the rigid 2. Is this a rigid 2D body? How do we get the current position? This is the transform. What am I missing? What am I missing? Oops. Something dumb, I'm sure. Let's change this. Let's put this. Okay, let's print out the player's global position. That will help, right? So if we go into the player, I need to get out of full screen, go to the player scripts, and should I do it in on physics process? I don't know if it matters. This guy. Print. Player. It's like global position. See what that gives us. I didn't save. Those coordinates are way different, but maybe that's because it's closer to the center. Okay, so then let's explicitly set the target to this coordinate. All right, and then we'll just set this position hard-coded to vector 2. Not moving. Still coming out to 0. I wonder if this is actually supposed to be local or something. Kind of stuck. Might have to look for a new tutorial because this guy did say something about like it doesn't work anymore. Let's see if it's in his notes. More advanced pathfinding. Video did get longer than expected. Do you have any suggestions for tutorials? To support, show transcript. Let's see if anyone else figured it out. I had to change expert var nav agent and enemy to on ready var nav agent equals nav agent since nav agent was being used as a single resource shared between enemies. Nice catch. I did as well instinctively. On ready. I don't know if that matters, but let's try it. Agent at on. Reset things. Now it's not set at all. Did you set it then? Oh. Already var nav agent equals. Got it. This is a way of setting it dynamically once it's ready. Okay, I wonder if that fixes it then. That could have something to do with it, right? Well, the local's still coming out to 0, so that can't be it. Annoying. All right, how do I get back to the enemy? Okay, let's try that. Navigation agent equals on ready. This guy doesn't like it. That's the path, right? Expected end of statement. That is end of statement. Oh. Supposed to be in a string. Yeah, still 0. All right. Well, maybe some time away will help. But yeah, definitely hit a roadblock. Find out more here. Yeah, I read a lot of these. It doesn't help. All right, maybe I'll join that guy's Discord or watch another video or something. Okay, I think I'm gonna take a break. Come back to this later with fresh eyes. Everything should have worked. What could it be? What could it be? Something stupid, I'm sure. Could be because I messed with the... Where was that? Transform stuff. Like, did I mess with something here? Scale. Oh, collision. Leave and velocity. Do we care about any of that? Stop on slope. I must not have saved that. I don't think I have any slopes or anything, so I don't think that actually matters. Grounded. Yeah. I don't think it's any of this. I think it's the casting to local is not working. All right. Well, how's your day looking tomorrow? So maybe we background stuff. And I'll read more up on this. All right. Well, hit me up, and then you can try that tile map thing, maybe. That might be interesting to try out. Okay, later, guys.